Okay, by popular request, I'm going to do a few problems today from your 5-8 assignment because people were having a hard time with this. Also, as far as the test, don't worry about the test at this point. We'll make do whenever. So this is problem number 4 from your homework. So it says sine squared minus cosine squared equals 1 plus cosine theta. So here's what I would do. You got cosine squared, you got cosine. I can change this to cosine squared. So I'm going to do that. I'm going to make this 1 minus cosine squared theta minus another cosine squared theta equals 1 plus cosine theta. Now I got everything in cosines. So I can combine my like terms here. 1 minus 2 cosine squared theta equals 1 plus cosine theta. Now I'm going to move this over here. I'm going to move all this over here. So if I add 2 cosine squared to both sides, I'm going to get 2 cosine squared theta. I'm going to still have my plus cosine theta. And then I'm going to subtract 1 from both sides, and I'm going to get 0. So I get this. Okay, now I've got a cosine. I've got 2 cosines, and I've got a cosine. I'm going to factor out the cosine. That leaves me with 2 cosine theta plus 1. And then I can break this into 2 problems since I have one number times another number equals 0. One of these 2 things has got to be 0, so cosine theta is going to be equal to 0, or 2 cosine theta plus 1 is going to equal 0. Okay, so cosine of theta is going to be equal to 0. It means that if I arc cosine this, I'm going to get, let's see, I'm going to get pi over 2. And I'm going to get 3 pi over 2. And then over here, I'm going to subtract 1. Divide by 2. And then I'm going to arc cosine negative 1/2. And I'm going to get 2 pi over 3. And let's see, I'm also going to get 4 pi over 3. Okay, now I can't remember on this problem if it had said that if there was a limit on here, like 0 is less than or equal to theta is less than 2 pi. If that's the case, then there's my 4 answers right there, because the period of both of these is 2 pi, and if I add 2 pi or subtract 2 pi onto these, I'm going to be outside that range. Okay. Some people have asked me, okay, how do I know when to use the 2 pi k thing? Well, this is when I know. If I don't have this limitation on here, then there is an infinite number of solutions to this problem. And so what that means is I would have pi over 2 would be an answer, but so would every whole number multiple of 2 pi would also be that. So I could add 4 pi over 2, I'd get 5 pi over 2. That would be another solution. And then another 9 pi over 2, and I could do that to each one of these. So if that was the case, I would take this and I would write, okay, theta is going to be pi over 2 plus 2 pi k. And that gives me all the answers that exist. Okay, I'd also have to write down 3 pi over 2 plus 2 pi k, because that gives me a different set of answers than this one. And so the same with both of these. 2 pi over 3 plus 2 pi k. And I would also have to have 4 pi over 3 plus 2 pi k. Okay, so depending on whether there's a restriction on this or not, depends on whether I have this for an answer or I have this for an answer. Hopefully that answers all your questions.